Well, we've almost completed Chapter 1. Hopefully we've gotten off to a good start and you have a solid understanding of all these terms that have come up in Chapter 1. Our last section is on polygons. The first thing we need to do is understand what is a polygon. A polygon is a closed figure with segments as sides. All of the pictures below would be examples of polygons. Some of them look like very similar shapes or familiar shapes to you, and some of them maybe not. But all of them are polygons. They are closed and they have no curves. They are all made with segments. For non-examples, we have lots of different examples. But here's a couple of them. Obviously, the one on the left has curves. The one on the right, there's parts of the figure missing. It is not closed. So there we have a polygon and what is not a polygon. Now, the types of polygons, we really would like for you to know the names of our polygons up to sides of number 12. So we have names for them from 3 to 12, but we don't have you do number 11. Number 11, if you're wondering, is an undecagon. Most of you knew that a three-sided figure is a triangle. However, a four-sided figure, everybody loves to call it a square, but we should call it a quadrilateral. There are many different types of four-sided figures, but the group of them is called quadrilaterals. We have kites, we have rhombus, we have parallelogram, rectangles, squares, and all kinds of shapes that have four sides. We group them all as a quadrilateral. From there on out, it becomes a little bit easier. We have the pentagon, pent meaning 5, hexagon, hexa 5, or excuse me, is 6, heptagon. There are some people that have had teachers teach them that a seven-sided figure is a septagon. That is correct, but it is uncommon. So we would like for you to know heptagon, the more common seven-sided figure name. 8-sided is octagon, nonagon, decagon, 12 is a dodecagon, and like I said, 11 we don't need you to know, but it's called an undecagon. You may want to press pause so that you can get all these names down, or else just copy them down from page 46 in your book. Now, as you'll notice, I've left one out. It says n sides. This is what we're going to use for all other shapes that are like 13-sided shapes, 26-sided shapes. All of these different types of shapes, although many of them have names, once we get past 12, we just like to group them as n-gons. So if we saw a 17-sided figure, we would just simply call it a 17-gon. We replace n with the number of sides that that figure had. A couple of words, concave and convex. A few of you probably have glasses and all of you have eyes. Concave and convex has to do a lot with lenses. Concave is when something dents in. Convex is when it bulges out. So you'll see on the picture there we have a concave lens. Both sides curve in. This causes light rays to spread apart. Another word for that is diverge. Then we have convex, meaning to bulge out. Now we don't care so much that you know about lenses, but we do need to understand concave and convex. The one being bulging out and the one being caving in. So make sure that you know the difference between the two of them. Here's the definitions for you. You write your own, and we'll talk about it in class if you have questions. Next is a regular polygon. A regular polygon is a polygon with all sides congruent and all angles congruent. Do you remember what congruent means? If you were thinking same shape, same size, then you're correct. So a regular polygon, all of the sides would be the same length and all of the sides would be the same shape, meaning a segment. The key here also is all angles congruent. If we didn't have that, you would see a few figures that would look very strange that we could also call regular. So we also need all of the angles to be congruent. There are 4 pictures below. All of them would be considered regular. Some of them have special names. Some of them we just call regular. The blue one I bet you all know the name for. If you were thinking square, you'd be correct. The triangle on the right is actually called an equilateral triangle. The other two would just be called a regular pentagon on the left in the red and a regular hexagon in the middle in the green. Remember, regular means all sides, all angles congruent. One example to leave you with today, the length of a rectangular garage is 6 times its width. Find the length and width of the garage if the perimeter of the garage is 280 feet. As your teachers have probably told you for a lot of years, when you get to a word problem, a good idea is to draw a picture. So in this question it is talking about a rectangular garage. It says the length is 6 times its width. So we know absolutely nothing about the width. So there I will put an X by the width. We do know something about the length. It tells us that the length is 6 times the width. So if the width is X, the length will be 6x. Now, do you know the property about rectangles that would be really useful right now? I bet you do. If the top side is 6x, the bottom side also has to be 6x. If the right side is x, then the left side is also x. Now, in this question, it asks you, or it tells you that the perimeter, I'll use P, equals 280 feet. How do we find perimeter? If you were thinking add up all sides, you'd be correct. So what we're going to do in this picture, or in this problem, is we're going to add the top plus the right side plus the bottom plus the left. And if I add up all the sides, I should get 280 because we're told the perimeter is 280 feet. Now if we add up all those pieces, I have 6x plus x plus 6x plus x. We are going to get 14x equal to 280. One last step to go and we're done. Divide by 14 on both sides and you're done. X equals 20. Now, remember, the last thing we should always do before we're done with the word problem is to check what it said to find. It said, find the length and width. So far, we've only found x. We need to put that x back in the problem. If we put 20 in for x right here, we would get 20 feet for the width. And if we put 20 in for x on the top, we would get 120 feet for the length. We've now found the two measurements and we've answered the problem. If you didn't understand anything from today's lesson, make sure to come and ask me in class.